Ladies and gentlemen, we are back at the keynote session. This session is something special. We wanted to bring something special from every part of the value chain. We wanted to have end users and integrators. But now we are going to the capital of optics in Europe. I always get goosebumps when I talk about Jena. And we go to the iconic instrument integrator in Europe. We go to JENOPTIK. JENOPTIK, you can talk to them from microscopy to speed cameras, from infrared to pharmaceuticals. You can talk to them about anything. Today, we want to hear about peak testing, integrated photonic testing, and laser micromachining. This company has made the sentence, every photon counts, a business. And with us, we have Thomas, who is here to tell us about what partnerships can they do in integrated photonic testing and laser micromachining. Let's all of us, the 700 EPIC members, help JENOPTIK be even greater than already is. Mr. Thomas Tellerts from JENOPTIK, welcome to Photonics Plus.
Yeah, thank you very much, Jose. Thank you also the team for the introduction. Welcome to the audience. Welcome to my presentation along the photonic value chain from optical components to from photonic solutions to optical components. I will first share my screen. Wait a second, and then we will go ahead. So my name is Thomas Strelitz. I'm expert innovation at JENOPTIK, and I belong to the corporate development. And I have the honor to introduce you JENOPTIK in some specific areas. My presentation is structured in, at first, who is JENOPTIK? Yeah? Then we will have a deep dive into certain applications. And afterwards, we will talk about room for collaborations. At the beginning, I want to show you this one. This image was taken in a German TV in the mid of February, where we JENOPTICans were very, very proud of it. It was an image of the Mars rover Perseverance when he landed on the Mars. It was an astonishing image, and we can say, okay, we provided here a significant amount. The images was taken by the HES camera, and we were the one who were providing these camera assemblies to generate these pictures. In total, we have manufactured for this mission 3 high-end objective assemblies, which are now in use for avoiding collisions, navigation, and gathering of the specimens in their cache cam. And it shows really already the DNA of our JENOPTIK. Yeah? It's manufacturing high sophisticated optics and assemblies. But where is it coming from? JENOPTIK has a long-term history, and it goes back to the 1846 year when Carl Zeiss and Ernst Abbe founded together the company Carl Zeiss Jena. Our origin goes back to that history, and JENOPTIK itself was founded 1991 after the German reunification, but the brand itself was already used during Eastern Germany times to sell the products outside. Today, we had 2 days ago our 30 years anniversary. We have been a globally active company with 760 million of revenue and with 4,500 employees worldwide. And we are making our business in 3 photonic areas. We have our light and optics. We are really provider of OEM key technologies based on photonics. Then we have the light and production area. We are experts in smart manufacturing using really photonics in that area. And the light and safety, we are providing photonic solutions on the street side to make our roads and communities safer. I would now go a bit into some applications, and I would like to start with our light and safety. 1958, we were the first one who were developing the first ever radar-based speed enforcement camera. Up to now, we have developed from a hardware provider on the street to a provider of traffic law enforcement for smart cities. It's not only the hardware on the street capturing the scenes and the data, we are processing them, we're putting it in the back office, and it's possible also to provide it to the police officer through this smartphone. And hence is all this through data science, where we evaluate the data, and we, for instance, here we have our ANPR solution. It's the autonomous number plate recognition, which is used to detect stolen cars maybe in advance, or to prevent criminal behavior by checking, okay, is there an anomaly or not? And here we see something in the future. Think of, okay, what happens if we have autonomous cars driving? What happens with the traffic law enforcement? They will decrease. But one thing is still open. Autonomous driving car cannot look behind the corner so far. And we will take a look here to be the enabler to use our infrastructure with the car to enable fully autonomous driving. Coming now from the streets back into the production facility, we have here our light and production. We offer here solutions from standalone machines up to complete manufacturing lines using 3D laser processes and optical inspection technologies. To give you an example, I've provided here, you can see an application of a highly automated manufacturing cell, which is here used for the application of fixture-free tube cutting. It's really high efficient in the area of the elements. The movements are so adjusted that we have minimal moving parts, and we have an automated waste removal. And to show you a bit the complexity, you can see it here on the picture. The process is really, we have combined here image processing and inspection to measure at first, okay, what kind of tubes we have, what tolerances. Then we have a handling robot grabbing the tube, and the laser processing robot is doing the processing. And here in that case, it's cutting. And this is all done simultaneously and done at the edge of the physics. Going now from our, I would say, photonic journey to our heart of our optics. We are here in the light and optics. And in light and optics, we are provider of from high-end components up to complete customized optical engines and models. Starting with high individual lenses in micro optics, beam shaping, beam splitting, standard optics, up to f-theta beam expanders, infrared camera modules, up to intelligent engines. And we do this, and we profit here really from our expertise in manufacturing, assembly, and testing in-house. I would like now to dig into the latest applications or latest innovation here. And we see here some examples. Products get more and more accurate, and to enable this functionality and quality, laser processes are required. We see it in the automotive parts where plastic welding needs high requirements, moisture protection, and in the consumer electronics where we have ever more complicated devices lead to multi-materials and printed materials which needs to be manufactured with tighter tolerances. Then in the area of production, where battery production, we have a safety issue, and in the medical devices also where it's important to have precise and traceable production. But we have every time one issue with these laser processes. They need to be robust and reliable, and think of it, if you're working with the thinnest knife that you have, it's very hard to put it on the device. You can say you need to find a needle in the haystack, and you need their expensive fixtures to guarantee this accuracy. We see it here on the left side on the images, a part which is every time different oriented. And the thing is here, we developed a solution. It's an optical engine combining really the laser beam control with machine vision and a coaxial camera to detect the orientation of the part and to position every time accurate the laser beam on the part. You can see it here every time, depending on the orientation, the system adjusts to it. And with our modular weld, it's possible to solve this problem and to enable really jigless processes. We see it here for this plastic welding application. Going now to the next slide. We all know we have fielded now before the lack of data, but to put it simple in words, like Netflix drives the optical communication. We have a big amount of data, and they need to be processed very fast, and therefore higher data rates are required. And to ensure that higher data rates, or to generate them, we need optical communication, and their PICs are a core component. The advantage of PICs or silicon photonics here is really that they can be produced on a wafer using the CMOS technology, but they need still to align with the current standards, and the cost must be reduced. As Jenoptik, we are seeing that optoelectronic testing plays here really a big role. Today, PIC testing is very demanding. Why? It's separated done. It needs to deal with high tolerances, and the systems that you can buy are highly individualized and were not working parallel. Therefore, a plug-and-play solution is required, enabling parallel testing, working with the coarse alignment on the prober, and therefore we developed the UFO probe. It's our ultra-fast optoelectric probe card. It's a standard probe card in a Eurocode format. You can see it on the left side, where it's possible to measure electrical and optical probing in one touchdown. And this is easily integrated into the wafer level with a direct output of, you can see it on the right side of these three outputs of wafer maps, where we can see really the electrical and optical wafer map. The good thing here is really that we've integrated it already in a machine, and we've already demonstrated really that it's working. And we are really looking for further chip designs and more channels to measure. Coming now to the last point, okay, where's the room for collaboration and answering the questions? What can Jenoptik do for you? We solve your optics challenge, really from the components up to complex systems. Please talk to us. We can be also your first client. If we have a new technology enhancing really our products, we are every time open to talk and to develop together. And for the last thing, it's really, we want to be the enabler for intelligent and accurate laser processing when it comes to micro processes, micro laser machining processes. Or, and the last point here is really we want to be the enabler for parallelized PIC testing. What can you do for us? We're always looking for photonic technologies and for integration in our products. I thank you. I'm now open to questions.
Thank you very much, Thomas, for a great presentation. If you will, could you please stop sharing your screen so we can see each other nicely? Thank you very much, Thomas. It was a really great presentation. I like both aspects. On one hand, the PIC testing, the other one, the laser micromachining. Let's start with the small one. Let's start with PIC. For me, it is quite spectacular how very fast Jenoptik has positioned itself very quickly on helping the company. Something as important as wafer level testing. When it comes to making a probe head, like you are talking about ultra-fast optoelectronic probe, are you only testing DC, or is it interesting to actually have dynamic testing at wafer level? In the sense of testing also the modulators, or checking the bandwidth, or even the bit error rate of some of the active components?
I think I cannot answer this question that detail, but for now we are it's working for the grating couplers, and since we have not the background in this semiconductor, we need to see at first the applications think my colleagues Tobias Knausch might answer this question better. But we are every time looking for these new chip designs, and I think we can. I would say that it might be I would not exclude this.
All right. I do believe that the present of peak testing is to testing DC components. The future is to go into the dynamic testing at wafer level. I think we are going there, and JENOPTIK is the right company to go into that. One more thing, you talk about the probe testing using vertical grating couplers, which are a standard building block in silicon photonics. But in other technologies, we don't have vertical grating couplers. In other technologies, the light is actually butt coupled at the edge of the lasers, at the edge of the cavities with, for example, indium phosphide technology. Is there a solution for that? Can you actually do still testing if the light cannot be coupled upwards?
I think I cannot answer this question. And
no, but don't worry about that, because for me, what I wanted to go with this is where I wanted to go with these questions is that here, when you have the optical module, is the heart. For me, one thing that you have done very well at JENOPTIK, and on that I would like to congratulate you. You managed to use your expertise on light guiding and beam shaping into making a probe head that actually can be an optical probe head, and that is very unique, and that it really shows how JENOPTIK is an example on instrument manufacturing. What is the next step? What is the next thing that you want to do with the community now that the probe head is available?
I think we are, as mentioned before, we are now looking really for more applications, new chip designs. We want to extend really the channels for it. And so it's really that we want to have it try many other applications out, and develop really the platform for other needle types.
We have questions in the chat for you. The first one is coming all the way from, not very far away from you, from Germany, from Dresden. Sajay Charania, thank you very much for your question. Isn't photonic integrated circuit measurements very time consuming? What time do you estimate for a 100 millimeter wafer being tested?
I cannot answer this question.
The question here, it is more, you claim ultra-fast probing. Ultra-fast probing. Do you want, what is, in your opinion, the amount of time, or why is it ultra-fast? How did you design that probe to be ultra-fast?
For the ultra-fast, we would say it's really that we are doing the testing in one touchdown. Yeah? And instead of have it separately, and that's for the first one. And I think the next part is really to extend the size of it, make it bigger. But I cannot. I have not the details to answer this question.
I have all the details. So if anybody wants to know about peak testing, we have worked very hard at EPIC already for 2 years. JENOPTIK is one of our key members on this, but we have an entire supply chain for that. Thomas, let's move. Let's allow me to shift gears to talk about laser-based manufacturing, which is a passion that we both have. You talk a little bit about laser cutting. When it comes to laser cutting, what I have seen today is that we do have the laser right now, any laser that we need for laser cutting, from 12 centimeters of steel all the way to 3D laser cutting of metal, everything is available. The problem is in the inspection. I think the problem right now that we have is actually to have a real-time monitoring of the accuracy of the cut. For many years, we've seen S-Weir cameras as being perhaps the right technology. What is, in your opinion, the main system for monitoring laser cutting?
The main system for you mean in the I mean, at first we are every time using somewhere like a laser profile measurement system, in this 3D laser system, and then it really depends. Yeah, I mean, I think there's not an accurate answer to this. And there's every time the case that really the photodiode is always the fastest.
one more thing, we have a question in the chat coming from the EPIC head of photonic market research, so a person very dear to me, Tracy Vanik, all the way from California. And she's asking, self-contained system of laser robot plus image recognition plus communication, what is the status? When you have the robot, the image, and the software, what is the state of the art on that, and where do you see yourself, Jenoptik, being in the future for this, for the integration of robotics, laser, and image recognition?
I think image recognition or itself, the measurement of the part, the optical inspection is very important. It goes really in the area of really 3D inspection and 3D measurement. And we have our automation integration. That means we are working on that. We don't want to be the only one who provides only the standalone machine. We want to build really the fully solution. And yeah, that's the area, and we are every time looking on that machine vision applications, because it's eased a lot of problems in the beginning for us. And yeah, we need every time customized solutions because because of the complexity. It's every time I would say in different system.
In the field of laser micromachining, one of the tendencies that I think in the industry is to have a beam shaping that actually accommodates to every single process. So actually tunable, customizable, on-the-go beam shaping. Adaptive optics are considered one of the solutions. There are others. Have you seen a trend, any trend in beam shaping for laser micromachining? Anything that made you excited in the last 2-3 years?
I cannot answer this question. It's a trend. We are working on it, but for the system that we have just shown, that was not that important to solve the problem so far. That we have a different kind of beam shaping. I mean, it's every time really the point. Okay, what application we have, what laser source we need. Then we have really the positioning, and then it's really often the software which needs to adapt to this to positioning.
One of the companies in the chat that is asking question is the company Actar, Alexander Tele, and Actar develops black coatings for having high absorption. Do you see any application? Do you see any trend, any need, anything that you could see? Okay, maybe there is room for cooperation here.
I mean, we are now in the corporate. I have really the point that we can talk, and then I can really distribute it to the relevant persons. There we have to talk. Okay, what kind of improvements it might have to our system then.
Thank you very much. We are, I mean, detecting, I enjoy so much talking to you that I run out of time, and the Fleet Events team is already telling me, Jose, you have to stop this, you have to go to the next one. I would like to say one more thing. Thomas, I'm such a huge fan. I'm such a huge fan of Jenoptik. And every time I put Jena in my GPS, it says Carl Zeiss #1 Jenoptik. That's your address. I can't wait to start traveling again and to visit you in person. There is so many activities that we have done with Jenoptik, from microscopy all the way to laser micromachining, what you're doing now in peak testing, and what is coming very soon in quantum technologies. Everything is quite fascinating. Once again, congratulations.
Yeah, thank you very much. You're welcome to visit us.
Take care. See you soon. Bye-bye.
Bye.